Question number 2 is about bacteria. How many hours will it take a culture of bacteria to increase from 20 to 2000 if the growth rate per hour is 85%? So that's a very fast growth rate, and you'll find that to be the case with these questions about bacteria. Much astronomically higher than any kind of human growth rate or any animal growth rate that we might be studying, where the time it takes for another generation to be created is measured in years, not hours or minutes. So anyway, so we have our exponential base equation, right? We have y equals a times b to the x. We translated that into something that looked like a equals p, 1 plus or minus the rate, and we had it over t, but you know what, I'm not going to do that, over n, but I'm not going to do that right now because it's not a compounding multiple times per period, which is what that deals with. So I'm just going to do 1 plus, since it's growth, my growth rate 0.85, okay, and I'm just go ahead and use x, right? Could be t. I think in the example I gave you before, it's t. It really doesn't matter. If you want to use t because it's time and that would be helpful to you, that's fine. P was the initial amount, right? That's the starting amount. Doesn't matter if it's the starting amount of money you invest, the starting population, starting number of bacteria, whatever it is, right? Because if you think about it for a second, when t equals 0, then 1 plus 0.85 raised to the t becomes 1, and so I just get p. So now I'm just going to fill some things in, right? I'm not doing a function here, I'm solving an equation because I know everything except t. I have one variable. So I'm going to increase from 20. That tells me that's my starting amount. And I'm going to increase to 2000. That's where I want to get. My growth rate is 1 plus 0.85. Okay, so if I'm not putting it in a calculator and manipulating it more than just this one time, I'm just going to write 1.85. You can do either one. It really doesn't matter. And then we still have to the t. So now I'm going to solve that equation for t. So first step, of course, divide by 20. Trying to get t by itself. That 0 is going to go, and so I have 200 over 2. That's going to be 100. And now I have 1.85, don't need the parentheses anymore, to the t. And so now I can use, I'll just come over here, and I'm going to use my definition of log and say the base is 1.85, and so now I have log base 1.85. The exponent is t that I'm looking for, and that's going to equal 100. Okay, so log base 1.85 of 100 equals t. Same equation, just saying it as I write it. Okay, so this is what I'm now going to solve. So I'm going to put log of 100 over log of 85, 1.85, excuse me, into my calculator. Okay, so pretty quick. Log 100, close, divide, log 1.85. Take a look before you hit enter. Looks good. Make sure it makes sense. A little hard to know. With numbers like this, it's not something we're used to. But 7.48. Okay, so it's going to take more than 7 hours. It will be the 8th hour, 7.48. So T equals 7.48 hours. Okay? Did I answer the question that was being asked? How many hours will it take? 7.48. There you go. Okay? So it's not asking in which hour. So 0.48 is a valid part of the answer. So 7 hours, right? And 48 hundredths minutes. So if you wanted to get it all the way to minutes, it would take 7.486 hours. I would just subtract the 7, that'll leave the decimal, and multiply by 60, and that will tell me how many minutes, right? Well, we knew it was pretty close to a half, so 7 hours, I would say 7½ hours would be a very reasonable answer. If you wrote 7.48, I would take that too. That would be fine. Don't say 7 hours and 48 minutes. That would not be correct. That would be more like 7¾ hours. Okay, that's it for that one.